so that we can look at a different kind of proof, because I accidentally put the same kinds of proofs over and over again, and there's another type that are going to be on your homework. But before we go there, the parallel postulate is what we're going to use when we get to the constructions here in a little while. When we do our constructions, one of them we're going to do is to construct a line parallel to another line. And so the parallel postulate is why we can do that. It says that through a point P, not on line L, there is exactly one line that would be parallel to L. Do you agree that there is only one line that we could draw through this point P that would be parallel to line L? Okay, and so we're going to construct that line in a little bit. All right. So this is basically the same exact thing we did last class period. They give you 4 is congruent to 8, and they want you to write a proof. I'm going to remind you that in the homework, if it says show, what are you supposed to do? Write a 2-column proof, okay? I'm not going to work these easy ones over and over again that are in the notes. I'm just going to talk about it, and we're going to get to the harder ones. So this would, again, just be a simple 2-step proof like the first example we did last class period. They give you 4 is congruent to 8. If 4 is congruent to 8, what kind of angles are those? They're not corresponding. Alternate exterior. Look at the picture. Do you see that those are on opposite sides of the transversal and they are outside the lines R and S? Alternate exterior. We learned 5 converses last class period. One of them was the converse of the alternate exterior angle theorem. It said that if the alternate exterior angles are congruent, then the lines must be what? Parallel. Okay? So this would be a simple 2-step proof. Given, and then 4 is congruent to 8 gives us that the lines are parallel by the converse of the alternate exterior angle theorem. So you would only have 2 steps here. 1, 2, done. Super simple, just like the first one we did. That's a typo. They are exterior. I don't know why that's there. Are you guys good? Just 2-step there? Okay, so let's look at one that's harder. I'm going to change this one a little bit, though, because I want to work one that's different than the one we did in our notes already. So I'm going to pick a different one. Give me just a second to find one that works out good with numbers. I don't like that. 3 and 7. Okay, so we're going to do this. We're going to change this problem. So on your proof right here, fix this. We're going to cross this out. And we're going to change it to the measure of angle 6 is equal to 6x plus 18. The measure of angle 7 is equal to 9x plus 12. And x is equal to 10. And again, if you read the directions, it says to show that R is parallel to S. So when we see that word show, we're going to do what? 2-column proof. Okay, keep reminding you of that so that you don't make a mistake on the homework. Okay, so first thing we'll do is draw our 2 columns. Left side should be labeled statements. Right side should be reasons. And just like we did last class period, we will write all of that given down in our first statement. So we have measure angle 6 equals 6x plus 18 degrees. Measure of angle 7 is equal to 9x plus 12 degrees. And x is equal to 10. Good grief. And given. Then the next thing I would do if I were you is go to your picture and look and see what kind of angles are 6 and 7. Very good. Same side interior. What did we learn last class period needs to be true about same side interior angles in order for the lines to be parallel? Supplementary, SSS, same side supplementary. So we do not need to show that these are congruent. We need to show that these angles are supplementary. Okay, so keep that in mind. We want them to add to equal 180 and be supplementary. So what would be our next step? We're not really plugging x in, we're plugging what in? 10 in. We're plugging 10 in for x. So what do we call that when we plug something in for x? Substitution. So this is the same second step, just like the proof we did last class period. We're going to do substitution property of equality. And then we're going to substitute that in. So we have measure angle 6 equals 6 times 10 plus 18. And measure of angle 7 equals 9 times 10 plus 12. What would we need to do next? Simplify. Again, you could do this in 2 separate steps if you want to, or you can do it all at once, just like the last one we did. So you could either just do the 6 times 10 and the 9 times 10 and then do another simplify where you add, or you can do it all at once and say the measure of angle 6 is equal to 78 degrees. And then the measure of angle 7 is equal to 102 degrees. And we just multiplied and added there using our simplify. Okay, it's the next step that we did not practice last class period, and that is different on this proof. And I don't know that we may have talked about it once in kind of a fill in the blank proof where they did this, but we haven't really ever done it ourselves. So the next step in the proof, we are trying to get that they add to equal 180, right? So we need to add angle 6 and angle 7 together. Would you agree? Okay, so we're going to say number 4, the measure of angle 6 plus the measure of angle 7 is equal to, you're doing 2 steps at once, be careful. So we're going to add 7 over here to the left, and we're going to add 7 over here to the right. If you want to, you can do it the way they've done it. So I'm going to show you 2 ways you could write this. You need to do whatever is going to make more sense to you. This is what you had originally. We're going to add 7 to the left, and we're going to add 7 to the right. What's that called when you add something to both sides of the equation? Okay, addition property of equality. So either you can do this, measure of angle 6 plus measure of angle 7 equals 78 plus measure of angle 7. And then you could substitute in the value of angle 7. Or what they usually do is they just say the measure of angle 7 is the same as 102. And so they'll say add 7 to the left. And instead of adding the actual expression measure of angle 7, they'll just put 102. Does that make sense? You're still adding this measurement, which is the same, to both sides of the equation. So it's still addition property. So if you feel like that's more confusing, then write it as measure angle 7 and then substitute in 102. Or you can just write it like this and call it the addition property of equality. But then we'll have to go the step further, Cooper, to actually simplify that down. So this will be equal to 78 plus 102. And that is our addition property of equality. Stop me right now if I just confuse you on any part of that. We're really good? Okay. So then what's our next step? Simplify. So measure of angle 6 plus measure of angle 7 is equal to 180. Simplify. And if you go back and read your converse, it says if the same side interior angles are what? Supplementary. So we still have another step we need to do before we can say that the lines are parallel. This says they add to be 180. What does our next step need to say? They're not the same angle. Remember, 6 and 7 are not necessarily congruent. They're supplementary. And we just proved they're not the same angle. 178 and 102. Say it again, Anna. Exactly. Read your converse again. If what? If the same side interior angles are supplementary, then the lines are parallel. We haven't said that they're supplementary. What have we said? That they add to equal 180. That is a different statement. Even though it means the same, it's a different statement. So we need to go a step further to say angle 6 and angle 7 are supplementary. What tells me if they add to be 180 that they are supplementary? Nope. Say it again, Ivan. Definition of supplementary. Definition of supplementary. We're running out of room, so I'm just going to abbreviate there. Don't abbreviate on your homework. Okay, now, if 6 and 7, which are same side interior angles, are supplementary, what does that mean about the lines? That they're parallel. And the lines were R and S. So R is parallel to S. And what's the reason? Okay, Anna's got it. The rest of you are super quiet. Are you with me? What were the two words that have to start every reason if we're stating lines are parallel? Converse of. Thank you. So this is converse of. And then we look at the picture and see the angles are same side interior. So it's just converse of same side interior angle theorem. Questions on this one since it's a little bit different than the last one? Okay, you have 3 proofs in your notes right now that we did, and they're all different, but they are all exactly the same as what you're going to see on your homework. So if you're trying to prove, do you have a question, Denise? This? Yes. Okay, I'm going to come back to you in just 1 second, okay? On your homework, the proofs you're going to have to do that are like this, where they give you information and they say, show that the lines are parallel. They're either going to be a simple 2-step proof like the first one we did. They're going to turn out to be angles that should be congruent, so they'll look like the second one that we did. Or they'll turn out to be angles that should be supplementary, and that means you'll follow this exact same process. Okay, so there shouldn't be a whole lot of guessing, what do I do? If you look back at your notes, they will be identical to what we have done. And then the more you practice that, the more it's going to make more sense. Okay, so Denise, back to this. So we had this equation in the proof, right? Measure angle 6 equals 78. We want to show that these two angles add to equal 180. So what we need to do is add angle 7 to angle 6. But whatever we do to the left side of the equation, we have to also do to the right side of the equation. Oftentimes, students don't see this as addition property going from here to here because these look different, right? So what is helpful for you, if that doesn't make sense, is don't write it that way. Write it as measure of angle 7. So then we added 7 to the left, we added 7 to the right. That's the addition property. Then go a step further and say measure of angle 6 plus measure of angle 7 equals 78 plus 102 by substituting in the 102 for angle 7. And so you would just have an extra step, and if it makes more sense to do it that way, it's perfectly fine. All I was saying was you can get away, and the book does this. They often add 7 and add 102, and because they're the same measure, it's still adding the same thing to the left that you added to the right that keeps your equation balanced. But to me, it's easier to see if you write it as 2 separate steps. Does that really make sense? Okay. Everybody else, questions? Okay. Good, Joy? Sure? Okay. All right, so we're going to practice a few more proofs. but they will be different than those. Okay, so now if you've done the homework or looked at 3-3, what you'll notice is there are some proofs that are not just like those, where they give you measures of the angles, but they look more like this. I want to warn you, there are a couple proofs on your homework that say, write a 2-column proof of the alternate exterior angle theorem, or write a 2-column proof of the same side interior angle theorem. You can't use that theorem if you're writing a proof of that theorem. Does that make sense? So I was helping some students this morning before school, and several of them had as their last reason the name of the theorem. But that's what the proof is all about. So you cannot use the name of the theorem if that's what the proof is about. So read your directions carefully. If it just says given proof, you can use anything we've learned. But if it says it is a proof of this theorem, don't use that theorem in your proof. Okay, I want to clarify that because I didn't say that last class. I believe there's a typo. No, there's not. This one's right. Oh, yes, there is a typo. What is our given here? What did they mark in the picture? That is wrong. This should not be marked parallel. That's what we're trying to prove. P and R should be marked parallel. So please fix your picture. Okay, the given is correct. The picture was marked incorrectly. Yes. All right, so P is parallel to R, and then they tell us 1's congruent to 3. Did I give you guys a statement and reasons box? Yes? Okay. So we're going to go through. We're going to write a 2-column proof, statements and reasons. Oops, that's okay, number 1. P is parallel to R, given. I'm going to stop right there. If P is parallel to R, what is something that you could say based on the picture if P is parallel to R? Very good. If P is parallel to R, what kind of angles are 2 and 3? Alternate exterior. And so the first 5 theorems we learned, not the converses, said if the lines are parallel, then the alternate exterior angles will be congruent. So from this given, we could say angle 2 is congruent to angle 3. And what's the reason? Very good. Not converse because we're not proving lines parallel. Alternate exterior angles theorem. Okay. Now let's go back to our given. We also were given that 1 was congruent to 3. So angle 1's congruent to angle 3. Number 3, given. You could have written that all at once, but I think it's always helpful if we can to write down one given, come up with what we know from it, write down the next given, come up with what we know from it. Okay, now look at what we have in 2 and 3. 2's congruent to 3, 1's congruent to 3. What can we say based off that information? 1's congruent to 2, good. So angle 1 is congruent to angle 2. Why? What did we use to get that? Careful, transitive property of? Congruence, because our symbol is a congruent symbol. Good, Weston. So transitive property of congruence. Okay, so let's mark that in our picture. We had 2 was congruent to 3. So I'm going to go ahead and mark that. 2 is congruent to 3. We had 1 was congruent to 3. And now we have 1's congruent to 2. So now we have all of these angles are basically congruent to each other, right? Our goal is to prove L parallel to M. So now look at the lines L and M. What kind of angles do we have here? Corresponding. And so if the corresponding angles are congruent, what can we now say? Then the lines are parallel. So that goes back to our 5 converses that we learned. If 3 of our angles are congruent, corresponding, alternate interior or alternate exterior, or if the other 2, same side interior or same side exterior, are supplementary, then the lines must be parallel. So now we can say our last statement, L must be parallel to M. And what's going to be our reason? Close. What two words did you forget to use to start with? Converse of. If your statement is about lines being parallel, then your reason, if you used a converse, your reason must be converse of. And then what kind of angles were they? Careful, that's lines. Corresponding. So converse of the corresponding angles, what? Postulate. Good. It's the only one that was a postulate. The rest of them are theorems. Questions on that kind of proof? All right, you'll see several problems on your homework like this, where you have to use that idea of transitive property to come up with getting the lines parallel that you need. Okay, so let's look at, I think we have one more left in the notes. Is that correct? Yes? Okay, let's do this one and then we'll move on to 3, 4. So we're given 1's congruent to 4. I'm going to go ahead and mark my picture. And we're given that 3 and 4 are supplementary. So I'm just going to put that those are supplementary just to remind myself when I'm looking at the picture. And we want to prove L parallel to M. Okay, so let's start with a 2-column proof and see if we can work our way to where we need to get to. So statements, reasons. Start with our first given that 1 is congruent, angle 1 is congruent to angle 4. Given. So if 1's congruent to 4, looking at those green angles, what would that tell us? 2 is congruent to 3, but it is not because 1 was congruent to 4. What does 1 being congruent to 4 tell us? That doesn't come from 1 being congruent to 4. What does 1 being congruent to 4 tell us? What's parallel? Okay, so if I look at that picture, what kind of angles are 1 and 4? Alternate interior. And so the lines that make those angles, which would be L and N, should be parallel, right? Okay, are we trying to get L parallel to N though? No. Not 1 and 3. We need some information to get L and M to be parallel. We need information about 1 and 2 because those are the two angles made by these two lines. There's not a relationship between 1 and 3. Those are not corresponding alternate interior, alternate exterior, same side interior, or same side exterior. What are 1 and 2? Okay, same side interior. So what do we need to be true about 1 and 2? Okay. Actually, it doesn't say if they add to be 180. What does it say? Very good. So we will need to get that they add to be 180 so that we can say they're supplementary. So if we can get 1 and 2 are supplementary, do you guys agree that that would make L parallel to M? Okay, so ultimately that's our goal. Let's see what we know. We could say L is parallel to N, but that's not really going to help us at this point. So we don't just want to add things in our proof that aren't necessary, even though that's true. So I'm going to go back to what Weston said a few minutes ago. What do we know about angles 2 and 3? Okay, they're congruent. So let's go ahead and add that down in our proof. So number 2, angle 2 is congruent to angle 3. How did we know that? They're not a linear pair. Vertical. They're vertical angles. Vertical angles are the ones across from each other when two lines intersect. So what is my reason here? Good, and it's vertical angles theorem. Again, my second hour class always says vertical because they had a lot of trouble spelling vertical. And now that they're in chapter 5, they have to be able to spell vertical. So they say vertical. Vertical angles theorem gives us 2's congruent to 3. Okay, we haven't used the rest of our given yet. So let's go ahead and write down the rest of our given. Number 3 was that angle 3 and angle 4 are supplementary. And that was given. So what does that mean if 3 and 4 are supplementary? Very good. So we could say next that the measure of angle 3 plus the measure of angle 4 equals 180. And I would remind you to put those little M's. I am still continuously counting off on homework from back in chapter 1 notation. If you are using addition and equals, you have to have little M's, okay? So 3 plus 4 equals 180. How did we know that? Very good. Definition of supplementary. Okay. Again, remind me, what are we trying to get so that we can say the lines are parallel? Okay, we want 1 and 2 to be supplementary. And right now we have 3 and 4 are supplementary. So what do you see that we might be able to do here? Nope, we're going to have to show it using our algebra that we have here. Okay, that still doesn't give us 1 and 2 supplementary, so keep going. Okay, we're going to have to do something before we can do that, Anna, but she's right. Do you guys see that 2 is the same as 3? So where we have 3, we could put 2. And 1 is the same as 4, so where we have 4, we could put 1. But we can't take something that's congruent and substitute it into something that's equal because it's the substitution property of equality, right? So what do we need to do?
Make angle 1 equals angle 4.
And? Okay, so we need to go back and change these first 2 statements down here to say that those angles are equal. What tells us that if 2 angles are congruent, then they are also equal? Definition of congruence. And you can do that all at once if you want to. So we can say the measure of angle 1 equals the measure of angle 4, and the measure of angle 2 is equal to the measure of angle 3. And we can do that all at once since it's the same reason. Definition of congruence. And then Anna was right. We can substitute in 1 for 4 and 2 for 3 so that we can get 1 plus 2 equals 180. So I'm going to come over here where you can see better. This will be our number 6. And I'm going to use that substitution property of equality. Is everybody with me on what we're substituting? So this is going to say what here for number 6?
Measure of angle 1 plus the measure of angle 2 equals 180.
Exactly. And then what do we know if 1 plus 2 equals 180? Okay, then they are supplementary. And since the theorem actually says if the same side interior angles are supplementary, we have to go the step further to say angle 1 and angle 2 are supplementary. And again, what tells us that if they add to be 180, they're supplementary? Definition of supplementary. And now, if 1 and 2 are supplementary, what does that mean about our picture? Very good. So number 8 is what we're trying to prove. L is now parallel to M. And what's going to be the reason for that? Okay, but again, got to use converse of. You will get 0 credit if you tell me lines are parallel by the same side interior angles theorem, because that does not prove lines parallel. It's the converse of when your statement is about lines being parallel. So converse of, and then it is the same side interior angles theorem. Questions on proving lines parallel? No questions? Everybody's good? Okay. to mark this here for later. All right, so let's look at 3-4. 3-4 is more proving. Yay, huh? More proving. 3-4, though, is going to give us 3 more theorems. So before we get started, on the back, yes, on the back of your 3-4 notes, I want you to make 2 columns. Okay? One column is going to say ways to prove lines parallel. And the other column is going to say ways to prove lines perpendicular. I don't know why I wrote the word instead of just the symbol. I'm going to put just the symbol. Okay? We already have 5 ways to prove lines parallel. In this section, we're going to learn 1 more way. So we will have 6 total ways to prove lines parallel. Then we're going to learn 2 ways to prove lines perpendicular. And you will only have 2 ways to prove lines perpendicular. And that's what this section is about. Proving lines perpendicular with 1 extra way to prove them parallel. Okay? So let's list first of all our 5 ways to prove lines parallel that we learned last class period. This will be a good way to study for our test when you're looking back at your notes. What do all 5 of these start with? Converse of. Okay? So I'm going to write that down first, converse of on all of them. I'm really trying to stress that so that you don't miss it on your test. Okay? And so then what are our 5 ways? Converse of what? What's one way? Good. Converse of the corresponding angles postulate. What's another way? Okay, converse of the alternate interior angles theorem. Converse of alternate exterior angles theorem. And this may seem super redundant, but hopefully it's going to help it stick into your brain. And that'll make studying so much easier. Converse of, good, same side interior angles theorem. And the last one, good, so converse of the same side exterior angles theorem. Okay, so we have 5 ways right now to prove lines parallel. This section will teach us 1 more way. It is not converse of. And then we will learn 2 ways to prove lines perpendicular. Before we do that, we're going to talk about the perpendicular bisector of a segment. This will be our second construction that we're going to do today. We will construct the perpendicular bisector. You have already done that. We did it way back in chapter 1. Do you guys remember that we learned to bisect a line segment? How to do the construction to bisect a line segment? Remind me, how do we bisect a line segment if I do the construction? Okay, draw a line. Okay, so I draw an arc. And then what do I do? Very good. Do the same thing, right? I'm going to have to go this way, sorry. Oops. Very good. So that's exactly what we learned in chapter 1. You may have a problem on your homework tonight that says to construct. Sorry, you couldn't see that very well, so I'm going to darken over it. So where they cross are the parts we're looking for. And then we just used our straight edge to connect those 2 points to draw our line, right? Okay, we just called it a bisector back then. We said that that split the line segment into 2 congruent parts. What did it make this point? The midpoint, right? What we didn't say, which is true today, is that not only is this line bisecting this segment, but it's also what? It's perpendicular to the segment. It's going to create a right angle when you draw that in. So really what we created in chapter 1 was a perpendicular bisector, but we hadn't learned that term yet, so we just called it a bisector. It is actually a perpendicular bisector. So on the homework, if it says construct a perpendicular bisector of a line segment, you can do that just doing what we did in chapter 1. Okay? But we're also going to be drawing in perpendicular bisectors, or excuse me, perpendicular lines to other lines that are not segments. And so we're not going to be bisecting, we're just going to be drawing a line perpendicular, and that'll be a little different, and we'll look at it. Okay, so a perpendicular bisector is exactly what I just showed you here. It's going to be perpendicular, which means it's going to form a right angle, and it's going to bisect. So it's going to go through the segment's midpoint. Okay, so it is a line that's perpendicular and goes through the segment's midpoint. Okay, the next thing we need to talk about is what is the distance from a point to a line. So let's say I'm a point and the wall is a line. If I want to measure my distance from me to that wall, how should I walk to the wall? Straight, right? I shouldn't go diagonally towards Denise. I need to go straight to the wall. What should my path create with the wall? Okay, it's going to create a line, but what kind of line? Perpendicular. It needs to form a right angle. The shortest distance from me to the wall is going to be the perpendicular path. Would you agree? Okay, so that's what they say. When they tell you the distance from a point to a line, that phrase, you need to think that means the length of the perpendicular segment to the line. Not the diagonal distance, but the perpendicular distance. So anytime you draw the distance from a point to the line, you're always going to draw that perpendicularly. Okay? And that will be the shortest distance, because that's what you're trying to find, is the shortest possible distance. So the first part of the notes and the homework is not proofs. It is really easy. It just says name the shortest segment from point A to line BC. So find point A, find line BC. What will be the shortest segment that goes from point A over to line BC? Line segment what? AP. Not AB because it's diagonal, not AC because it's diagonal, but AP because it forms a right angle. And so it just says name the segment, so we would just put AP with the segment above it. Would you agree that's easy? Okay, just make sure that it's forming a right angle for it to be the shortest segment. Okay, the second part goes back to Algebra 1. It says write and solve an inequality for x. Write part A and solve it part B. So first of all, what is in an inequality? Very good. Less than or greater than. If it's not that, if it's an equal sign, it's called an equation. So an inequality should have a less than or a greater than symbol. We want to write an inequality for x and then solve that inequality. So if AP is the shortest distance, and it's 12, what does that mean about AC, which is x minus 8? Careful. If AP is 12, what does it mean about x minus 8? Very good. X minus 8 should be greater than 12, right? Okay, so that's what you're going to write. Really easy. X minus 8 is greater than 12. It said write it, so make sure you do that. And then it says solve it. So now we're going to solve it. To solve this inequality, what would you do? Just add 8. You're just trying to solve for x. So add 8, add 8. Again, this first part was part of your answer, though, so I'm going to circle it. That gives us x is greater than 20. And so when it says solve the inequality for x, we would say x is greater than 20. Now, I want to remind you of something important with inequalities. What do you do if you multiply or divide by a negative in the process of solving your inequality? Switches the inequality. So you may want to remind yourself here, because we didn't work an example like this, but you might have one on your notes, on your homework or on the test. If you multiply or divide only by a negative, not a positive, but if it's by a negative number, you have to flip the inequality sign. Okay, so if you multiply or divide by a negative, don't forget to flip the sign. Okay, so all those Algebra 1 rules come back in geometry, really important. Any questions on this? Okay, those should be easy problems. So now the rest of your notes should be proofs, right? We've got some theorems and then some proofs. So first thing you see here is the 3 theorems that are in this section. I'm going to jump down to the bottom one first because it's about proving lines parallel. So let's go ahead and finish our ways to prove lines parallel. We got our 5 ways on the board. 6th way to prove lines parallel. It does not have a name. So you are just going to have to write it out in your own words and just make sure you include the important words in it. It says if 2 coplanar lines are perpendicular to the same line, then the 2 lines will be parallel to each other. So if 2 lines are perpendicular to the same line, then those lines are parallel to each other. If you look at the picture, if this is a proof, I want to point out what you would have to have in your proof. They don't do a good job here in the notes, so you may want to add this. In your proof, you would have to first have R is perpendicular to T somewhere in your proof. And then you would have to have S is perpendicular to T. So that you have 2 lines, R and S, perpendicular to the same line, T. Do you see how we have 2 lines perpendicular to the same line? And if 2 lines are perpendicular to the same line, then those 2 lines, R and S, are parallel. Okay? So in your proof, you would have to have, they are each perpendicular to the same line. Now they're parallel to each other. So up here on the board, 6th way to prove lines parallel, does not have a name, does not start with converse of. It simply says, if 2 lines are perpendicular to the same line, then they, the 2 lines, are parallel to each other. If 2 lines are perpendicular to the same line, then they are parallel to each other. And if you want to, you can draw yourself a little picture here in your notes to remind yourself what it should look like. You should have 2 lines perpendicular to the same line. Therefore, that makes the 2 lines parallel. Any questions on our last way to prove lines parallel? Okay, let's look at our 2 ways to prove lines perpendicular. There's only 2 ways and only one of them has a name. The other one you're again going to have to write out in your own words. So let's start up here with the first one that does not have a name. And it says, if 2 intersecting lines form a linear pair of congruent angles. So think about that with me. Would you agree that these 2 red arcs are a linear pair when they're put together? Okay, and one arc and one arc means that they are congruent. So they're telling you that you have 2 angles that are congruent and they form a straight line. What do those 2 angles have to measure if they're congruent and form a straight line? 180 total, but what does each angle have to be? 90. So if each one is 90, would you agree that that means, oops, sorry. Would you agree that that means that the 2 lines have to be perpendicular? Okay, so here's what's important. You have to have a linear pair. Oh, I messed it up. Hold on. I'm so sorry. My fault. Give me 1 second, guys. So sorry. Okay, so here's what's important. Number 1, you have to have a linear pair. So in your proof, again, they don't do a good job of showing this in the hypothesis part. In your proof, you would have to have, maybe these are numbered like 1 and 2. You would have to have angle 1 and angle 2 are a linear pair. That would have to be listed in your proof. You would have to name the two angles that are a linear pair. Second thing you need is that the angles are congruent. So then you would have to have angle 1 is congruent to angle 2 somewhere in your proof. If they're a linear pair and they're congruent, then you can say the lines are perpendicular. Okay? So since it doesn't have a name, on the back of your notes, we're going to write out the theorem and use those keywords that we need. So we can say if two congruent angles form a linear pair, then the lines are perpendicular. And again, you just have to put it in your own words, but you have to have something that says they're a linear pair and they're congruent before you can say the lines are perpendicular. So I shortened it up a little bit to say if the two angles are congruent and form a linear pair, then the lines are perpendicular. And again, if you want to, you might draw yourself a little picture here that you need a linear pair of congruent angles. That's your goal. Okay, last theorem. It's called the perpendicular transversal theorem. So while we're on the back of our notes, let's just go ahead and list that over here. Perpendicular transversal theorem. Perpendicular transversal theorem. Let's talk about it and we'll draw a picture here before you flip your notes back over, okay? So look up here at the board and I'll explain it and then we'll fill in a picture. So perpendicular transversal theorem says, if a transversal is perpendicular to one of two parallel lines, then the lines must be perpendicular to each other. Okay, so here's what you have to have. They don't do a good job again in the hypothesis column, so you may want to go ahead and flip your notes back over, sorry, and add this in with me right now. They don't do a good job here. First of all, you have to have the transversal is perpendicular to one of the lines. So do you see here that N is marked perpendicular to Q? We would need N perpendicular to Q. So the transversal has to be perpendicular, hence the name, perpendicular transversal theorem. The transversal has to be perpendicular to one of the lines. And those two lines that are in your picture have to be parallel. So N is parallel to P in the picture. So if you're using this in a proof, you have to have those two things listed first. You have to have two parallel lines where one of them is perpendicular to the transversal. The other parallel line then, P, will also be perpendicular to the transversal. That's why it's called the perpendicular transversal theorem. So again, if you want to draw a picture back here on the back of your notes, you're going to have two parallel lines. Has to be given that they're parallel. And the transversal has to be perpendicular to one of those parallel lines. And then it will be perpendicular to the other. Those are the only two ways to prove lines perpendicular. A linear pair of congruent angles, or a pair of parallel lines where the transversal is perpendicular to one of them. Okay? So now we're going to look at a couple more proofs. How many proofs are in your notes? Will you guys look and see? Left. 2 or 3? 2? 2 or 3? 2. Okay. So let's look at some proofs here. Okay, write a two-column proof. Given R is parallel to S and 1 is congruent to 2. First thing I would do is mark my picture. R is parallel to S, 1 is congruent to 2. Then I would start writing my proof. Statements and reasons. You've got a box over there to the right, I believe. Write down your given. R is parallel to S. Given. Okay, stop there. If R is parallel to S, what is something we could say? Look at the picture. If R is parallel to S, what is something we can say that we've learned before? Exactly. 3 must be congruent to 2. What kind of angles are 3 and 2? Corresponding. So we can say angle 3 is congruent to angle 2 by the corresponding angles postulates. Not converse of, because we're not proving lines parallel yet. Just that those angles are congruent. Okay, now let's bring down the rest of our given. So number 3, angle 1 is congruent to angle 2. And this is given. And look at what you have in 2 and 3. 3 is congruent to 2. 1 is congruent to 2. What should we be able to say next? 1 is congruent to 3. Why? Not substitution. Transitive, because they both have exactly the same thing on one whole side. Angle 2, so that goes away. So this is transitive. Angle 1 is now congruent to angle 3 by transitive property. And is it of equality or of congruence? Congruence. So now we have 1 is congruent to 3. And we're trying to prove that R is perpendicular to T. So do we have a linear pair of congruent angles? Or do we have 2 lines parallel and the transversal's perpendicular to one of them, so now we can say it's perpendicular to the other? Okay, the top one. Do you agree that we have 1 and 3 are congruent in our proof? And what kind of angles are 1 and 3? They will be, but what are we trying to get? We're not trying to get that they're supplementary. What are we trying to get? We're trying to get that they're a linear pair and congruent, right? So we have they're congruent. Have we said that they're a linear pair? No. We need to state that before we can have our final conclusion. So we need to add into our proof number 5. Angle 1 and angle 3 are a linear pair. What told us that they were a linear pair? Exactly, Ivan. When we looked at the picture, they were adjacent and they formed a straight line. And that is the definition of a linear pair. So number 5 should be definition of linear pair. If I'm stating they're a linear pair and I have a picture, it's because of the definition. The way they looked defined their status. Okay, so now we have congruent angles and we have that they're a linear pair. And that's all we need for the first way to prove lines perpendicular. So number 6, we can say R is perpendicular to T. And unfortunately, it doesn't have a name, so you have to write it all out in your own words. Shorten it as much as you need to, but you need to make sure that you're stating that you had congruent angles that formed a linear pair. And that proved the lines were perpendicular. So somehow make sure to include those things. I wrote if 2 congruent angles are a linear pair, then the lines are perpendicular. One more, and we'll be done with the notes, and then we'll do a couple constructions. Okay? So this picture is a little crazy. But again, first thing I would do is mark my picture and then start writing down my given. The given is already marked in the picture this time. They have EHF, so it is already marked, is congruent to HFG. It's already marked. And then they have that FG is perpendicular to GH. It's already marked with a right angle. Okay, so let's start with our 2 columns. Statements, reasons. Number 1, list your first given. Angle EHF is congruent to angle HFG. Given. Again, I would tell you stop right there and see what does that tell you in the picture. What kind of angles are EHF and HFG in the picture? Okay, I want to make sure everybody's getting it with Anna. Do you see that this line makes the angle and this line makes the angle? Let me erase that part I actually drew extra there. And then this line makes this angle along with this line. Might help you to only draw those so you can see it. Do you agree that this angle and this angle then are alternate interior angles compared to those two lines? Okay, so if those two angles are congruent, what does that mean about the two vertical lines? That they're parallel. Remember our converses. If the alternate interior angles are congruent, then the lines have to be parallel. So which two lines could we say are now parallel? To name a line, you only use 2 letters, not 3. You're naming angles. Which two lines are parallel? F. Yes. So number 2, EH, make sure you put a line above it, is parallel to FG. Make sure you put a line with arrows above it. And what told us that? Okay, we're stating lines parallel, so it either has to be one of the 5 converses or it had to be the last way we learned today. This would be converse of, and the angles we had were alternate, interior, angles, theorem. Those are long to write out. Converse of, alternate, interior, angles, theorem. Okay, so right now we have a pair of lines parallel. I'm going to mark them in my picture. These are now parallel. Go back to our given. Let's write the next given that they gave us, number 3. FG is perpendicular to GH. Given. Now I want you to look at what you have here. You have a pair of parallel lines, and you have that one of those parallel lines, FG, is also perpendicular to the line GH. You've got a pair of parallel lines, and one of them is perpendicular to this transversal GH. Exactly. So we can go straight to what we're trying to prove here, that number 4, EH, is perpendicular to GH because we have a pair of parallel lines, and we have one of those parallel lines is perpendicular to the transversal. So that means the other parallel line had to be perpendicular to the transversal. And what's the name of that theorem? Perpendicular transversal theorem. Okay, it's going to take a little bit of time studying the theorems to really understand them and then trying to apply them. And once you do that a few times, it'll start to stick, okay? Any